Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will factorize non-monic quadratics. So this is part of the 10A course only. So if you're not doing that course, you don't need to go any further. This won't apply to you. So let's look at what non-monic quadratics actually are. So in a previous video, we were factorizing things like x squared plus 8x plus 15. And remember what we did was we just got two brackets, put an x in, two numbers that multiply to 15 and add to 8, 5 and 3, easy as. Right? So unfortunately, we can't use that method for all quadratics. So this quadratic here, we refer to as monic because the coefficient, which means, of course, number in front of, the coefficient of x squared is 1. If there's no coefficient written, we assume it's 1, okay? So, unfortunately, the techniques I've shown you thus far only work for monic quadratics. We're going to look at non-monic quadratics. So any quadratic expression can be written in the form something times x squared plus something times x plus something. Okay, so it's important. I'm going to refer to A, B, and C when I tell you how to factorize non-monic quadratics. So A is just the number in front of x squared, B is the number in front of x, and C is the number by itself. So, for example, if I have 4x squared plus 7x minus 20 here, A would be 4 because that's the number in front of x squared, B would be 7, and C wouldn't be 20, it would be negative 20. Okay? So it's important that we know how to do these. So I'm going to write up some steps for factorizing non-monic quadratics. So there are a few steps here. So what we'll have to do is find AC. Remember, A is the number in front of x squared, C is the constant term. Find two numbers that add up to the middle term B but multiply to AC. Split the middle term accordingly, and then we're going to factorize the first two terms separately, factorize the next two terms separately, and use the highest common factor. So it is a bit complicated, but you're very smart, which is why you're doing this. Okay, so let's look at an example. So we're going to look at an example of a non-monic quadratic. So another way of saying that a quadratic is non-monic is saying A does not equal 1. So let's try the example 2x squared plus 5x plus 3. Okay? So in this example, it's non-monic because A equals 2. Doesn't equal 1. B is 5, the number in front of x is 5, and then C is the constant term by itself, 3. So let's follow the steps. So AC is just 2 times 3, which is 6. So now I have to find two numbers that add to B, add to 5, but multiply to 6. And we saw an example like that in my previous video. So two numbers that multiply to 6 and add to 5 are 2 and 3. So what we do is we split this middle term here into 2x and 3x. So we write this as 2x squared plus 3x plus 2x plus 3. Notice that I haven't actually changed the expression because 3x plus 2x does equal 5x. So these two are the same thing. So that's what I mean, split up the middle term accordingly. So now I'm going to factorize the first two terms separately and the second two terms separately. So for the first two terms, they have a highest common factor of x. So what do I times by x to get 2x squared? I get 2x. What do I times by x to get 3x is just 3. The next two terms actually don't have a common factor, but I can still factorize them by taking out a common factor of 1. Okay? So now treat this as one term, treat this as another term. Both of them have a common factor of what's in the brackets. So I take that out the front, and then I'm left with x plus 1. Okay, now this is factorized. This is factorized like this. Okay, that's the process I'm going to follow for doing all non-monic quadratics. Note that the brackets in each case should be the same, otherwise you've done something wrong. So I'm going to rub out the blue and the red. Please pause and copy down if you need it, otherwise I'll go through another example. All right, so let's now look at the example 3x squared plus 2x minus 8. So I'm going to factorize this. It's non-monic because the number in front of x squared is not 1. It's 3. So a is 3. B, the number in front of x, is 2. C is not 8. It is negative 8. So we're going to follow these steps again. So first step, so a times c is 3 times negative 8, which is negative 24. So now I need to find two numbers that add to give 2, but multiply to give negative 24. So if they multiply to give negative 24, one's positive, one's negative. You need to look for factors of 24 that differ by 2, and in this case be 6 and 4. So I want the 6 to be positive and the 4 to be negative, because 6 plus negative 4 gives 2. So the numbers I have are, I'll just write them down, 6 and negative 4. So I'm going to split up this term accordingly. So I'm going to split up the 2x as 6x minus 4x. Okay, now I'm going to factorize the first two using highest common factor. So I'll take out the highest common factor of 3x. So what do I times by 3x to get 3x squared? What do I times by 3x to get 6x? Now I'm going to do the second two terms. So I'm going to take out a common factor of minus 4. So what do I times by minus 4 to get x? To get minus 4x. The answer is x. What do I times by negative 4 to get negative 8? So that's actually positive 2. So again, I have the same brackets in both cases. So I move that out the front. And I'm just left with 3x minus 4. Okay, note if I split up the middle term the other way, so I wrote, let's say I wrote it as 3x squared minus 4x plus 6x, so I put them in a different order, I'd still get the same answer. So if I was then going to factorize the first two terms, their highest common factor is x. So I get 3x minus 4. And then the second two terms, 6x and 8, highest common factor is positive 2. So I get 3x minus 4. You can see now that this is the common factor. So I write it out the front. I'm left with x plus 2. So it doesn't matter if when you're splitting up the second term, you get these two numbers a different way around. You'll still end up getting the same answer. Let's do one more example. So let's have a go at this equation here. This time, a is negative. A is negative 4, b is 9, and c is also 9. We're not going to do it any differently. So ac is negative 4 times 9, which is negative 36. We now need to find two factors of negative 36 that add to 9. So 36 and 1 won't work. 18 and 2 won't work. 12 and 3, well, yeah, they differ by 9. Let's see how we can make them work. So one's got to be positive, one's got to be negative. Because they add to positive 9, we want the larger one to be positive. So what we want to do is we want to write it as minus 4x squared plus 12x minus 3x plus 9. And you know how to do it from here. Let's factorize the first two terms. I'm going to take out a factor of minus 4x. Then I'm left with x minus 3. Now in the second one, I'm going to take out a factor of minus 3. And I'm left with x minus 3. Same bracket again. Move it to the front. And then what's left goes in the other bracket. So that should be minus 4x minus 3. Okay? And then we're done. If I expand this using FOIL, I should get exactly what I started with. So you can check your answers if you need. All right, this has been the luckiest maths teacher in the world. Thanks for your attention. Have a wonderful day.